So great. Hi. Thanks for coming. Real world serverless. Get settled. This will be right. I know there's lunch afterwards, so I know you're hungry, but give me the 50 minutes, please. Who am I? I'm David. I'm from Düsseldorf in Germany. You might recognize my awful German accent. And I work for Zenacor Technologies. We are a consultancy doing stuff. And you can find me with König Hotze on PlayStation, Twitter, GitHub, basically all around the place. 4 questions before we start. Who's doing microservices? Raise of hands. In production? Okay, cool. Quarter. And who's using containers? Rocket or Docker, something like this? Also, maybe a third. Who's running in the cloud? Public or on-premise cloud? Don't care. Oh, a couple of friends. Okay. And who has prior experience with serverless? Maybe the talk yesterday from Bert or something. Just 1. Okay. 2. Okay. Great. So expectation management. What can you expect from this talk? I'm not a vendor. I will talk a lot about AWS, but I don't care. My company is not a vendor. We have no preference. We do whatever we want. And I'm absolutely not a cloud guru. Amazon is far too complex to know everything, so I'm just doing my best. The next thing is my experience. You can see that's approximately the relation between my Java, Spring, Java EE, classical application stuff experience in contrast to my Lambda experience. Lambda is new, so I guess we have to learn there. And things are moving rather fast. Things are changing every day in the serverless landscape, so everything I will tell you now is out of date, and you can basically forget everything I said, okay? The story we are going to look at is what we learned with a couple of my teammates when we migrated our on-premise solution to AWS Lambda. And the application was an ASP.NET monster based on Microsoft SQL. And it's used for submitting billings. You know, I'm a consultant, so I have to submit my travel expenses and my customer billings and stuff like this. Really important. And we saw the serverless stuff and thought that would be really awesome to use that. And that was our architectural idea. That really was our architectural idea, nothing more concrete, okay? So do something in the cloud. And this was not so smooth. So we will look at some runtime issues like what languages can you use, what are the implications. We are looking at scalability and the promises Lambda makes or doesn't make or doesn't hold up, we'll see. And for the Perl users among us, we are looking at Lambda Tim Towdy. There's more than one way to do it, because there is more than one way. And we'll see that deployment still sucks. Even if you're just deploying Lambdas, deployment is always hell. Security is still important, even in the cloud. You should not submit your credentials to GitHub or something like this. And last but not least, some magic and witchcraft, namely hot and cold starts, where the magic happens. We don't have much time, just 50 minutes, so feel free to come to me afterwards if we want to dig deeper in one topic or the other, so I will keep things brief. AWS basic knowledge, somebody? Okay, so you are familiar with that, great. So back in the days, I'm now 40 years old, so back then when I started, I worked for companies like this, big gray buildings somewhere in Germany with a nice cellar, and there was this data center. And I guess most of us have something like this at the customer. And we moved to infrastructure as a service, and the idea was that working on real machines is not our main business, so we abstract away and we are using virtual machines. Who is using virtual machines? Still, most of you, okay. And then there was platform as a service, like Heroku or the old OpenShift, where the idea is that you don't care about the actual virtual machine, you deploy an application. And the silver bullet, namely Docker. Docker came along, containers, Rocket, Docker, whatever. And the idea is that you do not deploy virtual machines, you do not deploy big, heavy applications, but just tiny images which can run in milliseconds. They start in milliseconds, they stop in milliseconds, whatever. Totally easy, cloud solved, I guess. But if you go to production and you start thinking about Docker, there are some questions about provisioning. How do you scale? how do you monitor this mess? What about state? Security? Deploying? This is like drawing an owl. I don't know if you know that. It's a multi-step process. You start with the head, like circle for that, circle for the body, and then the rest. And it's the same for distributed systems. It's really the same. It's really difficult. The problems are hard. And there's one solution in the container space. And what is it? Any guesses? Of course, it's Kubernetes. We are so glad. And typically, when I start a project, there's 1 or 2 team members who are really fluent in Kubernetes because Kubernetes is so incredibly easy to use. And they start working on their concepts. You know, they go into office and they are doing all this stuff. And 6 months later, you end up with this. This is not made up. This is an actual architecture. And the cool part for me as a developer, I care about this. The rest is garbage. And I'm like, stop this, okay? Because I hate this. This is where serverless enters the place. So serverless, as we all know, this has been said many times, is an awful name. Let's look at the documentation. We won't read this. Just focus on the key points here. We can build applications without thinking about servers. There are servers, but we don't think about them. Somebody else scales them for you or monitors them. And you can, as a developer, you focus on what you are paid for. You focus on what matters, business logic. Okay? That's what they tell you. That's what they sell. And everybody sells that. Azure Functions, AWS Lambda, Google Cloud Functions, 1,000 products. I'll only use AWS. So I noticed not all of you know AWS, so a cheat sheet. When I say Lambda, I mean serverless compute. Piece of code that runs in the cloud. When I say S3, that's just Dropbox. Everybody knows Dropbox, so you know S3. IAM is the security stuff, where you protect things and things. And there's CloudFormation. Who is familiar with Terraform? A couple. So just think crappy Terraform. Then that's all. So for the rest of you, it's a tool for provisioning infrastructure. But we're here for Cloud Functions. What is a Cloud Function? It's just a piece of code that gets executed by an event. Something happens. Some user uploads a cat image. You get triggered, and you get executed. You actually do not have state. There might be some state lying around, which you can reuse. But in general, if you have state and you want to keep the state, you need a database. Surprise. And if you design your lambdas correctly, they should just do a single thing. If you name your lambda like creates an order, sends an email, and additionally creates 20 PDFs for certain things, then that lambda is badly designed. Just a single sentence. Regarding the execution model, as I said, they are triggered by an event. And lambda calls your handler. Nothing else. Totally easy, explained in one slide. The events can come from everything, from your browser, from your mobile device, from a message queue, from email, whatever. So everything could possibly call your lambda. The code is stored in S3. That means when you upload your lambda to AWS, they create an encrypted bucket. That's the bucket. And they store your lambda code inside. And when an event arrives, what happens is the following. AWS creates a container, basically a runtime. Think Docker. It extracts the source code in your runtime, and then it gets executed. That means the event gets processed by that thing. And if another event arrives in a short time frame, then we can obviously reuse that. We don't have to create another one. And if time passes, sometime, unspecified, AWS will just kill your instance and maybe create another one. Easy, right? Scale by request. This is the main selling point of serverless. You do not care about scaling. The idea is popular service, and there are many events. Yeah, like cat picture upload service. And instead of thinking about how do you scale, AWS does this for you. It just provides essentially as many lambdas as needed. So no more over-provisioning or under-provisioning. That's the idea. And for the managers among us, the coolest part is you only pay when this thing bounces, never paying for something that's just lying around. Okay, Who is a Java developer? What are you programming in? I think you two didn't raise your hand, so it's PHP, I guess. But really, Lambda supports many languages, and you can even, with a few tricks, use other languages than these. And you could definitely use Java for your Lambdas, and maybe you could even migrate your Spring application to serverless, but actually, no. We just found it too troublesome. It makes no sense. We are just using Node and Python because fast startup time, and you can actually work even if it's JavaScript. Maybe Go might be an alternative, I have no idea. So that's the general idea of serverless. You deploy some code, and it gets executed by events. Easy. Yeah, maybe not so easy. So what did we build? A serverless application. Now I think you all think like Netflix. 1,000 lambdas calling each other with events and kinesis and whatever. Actually not. What you see here is basically the general design pattern that we are using. We are hosting our single page application. You have to do a single page application because hype. In a bucket, so no server for the web application. The logic is just lambdas, lambda, lambda, lambda. So nothing else. And the database is a DynamoDB. So there is no server on this page that we have to maintain. It's a serverless website, serverless compute, serverless data. That's the way you should build your things. But there's no REST API gateway stuff. Really? And no event extravaganza? Yeah, right. You don't need it. You don't need an API gateway. You don't need to speak REST. It's perfectly fine to call your Lambda using JavaScript directly from your web page. And you won't pay for API gateway. API gateway is really expensive. And from my perspective, use it if you need, but we didn't use it. So let's talk about scale. Lambda scales by request. I've mentioned that. But for those developers of you who have a backend system, do you have a backend system that scales by request? Any of you? Maybe your Wildfly? No, I don't think so. Huh? And the problem is we have a legacy API for submitting billings to our backend processing stuff. And the idea was somebody comes along, uses the web page, calls the Lambda, and submits a bill to the billing API. Why not? At the end of the month, this happens. All the consultants, those are developers, you see those t-shirts. They submit their bills at the same time, and this is a status diagram from our monitoring tool, and the billing API just blew up. And we had a status call with the administrators of that thing, and they weren't too happy. I'm the guy with the beard, but they put me to the stake, and was awesome. So even in serverless, you have to think about capacity. You do have to use concurrency limits. You cannot just hit your backend or your database or whatever 1,000 requests per second at the same time, and because things will blow up. So just set concurrency limitations. That's like a throttle. You mean like throttling requests? But then you have to think about, if I throttle down to the database, that means just 10 requests at the same time maybe, then those bottlenecks tend to move upwards in your stack. So you definitely need to integrate your stuff asynchronously. That's the real diagram. We are moving to the lower part. You see the DynamoDB, yeah? The idea is that instead of hitting the billing API directly, you set up a different trigger. That's the new bill. That's a red Lambda, calling into a message queue, and that queue itself triggers a different Lambda. So you have a two-step back-off for your billing API. That's a general pattern. That's the only time that we use really event-driven architecture or design in our application, just for protecting our backends. But this is not enough. The attack of the self-denial. Actually, concurrency is limited. I thought I could go to serverless and do whatever I want and hit millions of requests at the same time. Actually, no, there are account limits. And you definitely need to read that up. You can find this in the documentation, like here. It's written down, concurrent executions, blah, 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 1,000. That sounds like much, but if you're working for a financial institute like Deutsche Bank or whatever, 1,000 concurrent processes is not that much. So I explain it differently. Let's say instead of 1,000, it's just 4. And you have a user system that's really popular. It gets 4 calls. So Lambda can provide 4 containers, 4 runtimes. And if at the same time budget gets called, can't be processed, has to wait. Blocking system, you don't want that. So this is shared nothing Lambda edition. You do not want to share resources, even Amazon resources. So we split it. We set up different accounts. This is just basic AWS. So instead of just having one big account for all systems, you create a system with an account for a user, system with an account for project, the same for budget. Really easy, can automate this. This is boring. Let's talk about how we get there. I had the impression that not all of you are doing Lambdas right now. So you're maybe thinking about how can I move there. Let's say you have a microservice for processing orders and you want to go to serverless landscape. There are 3 patterns. You can actually use one Lambda, you can use multiple Lambdas, or you can really refactor the hell out of your application. So the first thing, one Lambda with a dispatch. Everybody's building things like this, yeah? It's just a microservice, maybe written in Node or whatever, with those 3 functions, creating orders, forwarding an order, and canceling an order. And the idea is just you put a Lambda in front of it and let it dispatch. And that's really cool because in that sense, you can configure the Lambda as you see fit. Your business logic is clean and vendor unspecific, no Lambda inside. And you can reuse your assets really fast. But the downsides are clear. You cannot really configure the memory settings, for example, to match your specific Lambda. There's one Lambda, one size fits all. It's like those T-shirts, large, extra large, so that it fits everybody. And from a security perspective, this is also a nightmare because your Lambda has to basically have all permissions of your applications. And we'll talk about this in a couple of minutes. You won't want that. So what's the difference? Multi-Lambda with the same zip. Let's say we have this, once again, this microservice. We just create multiple Lambdas. One Lambda, for example, per REST endpoint. And by the way, that's like this serverless Java framework from Amazon. That's what it does. It just wraps your existing Java application and forwards those requests. The idea is that you have, for each function you want to expose a different Lambda. You can configure Lambda the way you see fit, and you call into your application. Free lunch? I don't think so. Okay, transitioning to that solution is really easy, but think about flexibility. That's still a monolith you have to deploy. You have dependencies in your Lambda code, which you probably don't need. So from a security point of view, this might be really a problem. And deployment, although better than before, it's still a nightmare because you have to maintain this monolith in a zip file and you have to deploy it multiple times, maybe inconsistencies. You get the idea. But the complexity is handlebar. So what's the holy grail? Multi-Lambda, shared nothing. Who is basically not aware what refactoring is? Anybody? That has changed, great. Nobody. So the idea is to refactor your application. You take your application, you split it, or you throw it away, depends, and you create different Lambdas for different functionality. That's where you want to end up. That's the goal. As I said, tiny names, tiny functionality. That's not easy to get there. But the flexibility is obviously that what you want. You can scale your Lambda exactly as you want. You can refresh the Lambda exactly as you want. You can size the Lambda as you want. On the other hand, your ops guys or your ops team might have some problem understanding what you are doing. Instead of one application, 200. That brings me to deployment. You might ask, what's to deploy? Yeah, a lot. Those are the frameworks basically you will find on AWS, which support coding for Lambda, like Serverless. Serverless is an awesome framework, which wraps basically AWS in a nice vendor-agnostic cocon. But you will find that you don't need any of them. I think you can definitely code against the Amazon API. But vendor login, yeah? Who is basically afraid of vendor login? Like, really? That's the same discussion I had in the past with those guys, Log4j versus Commons logging. Back in the day, that's 2003 stuff. There was Commons logging, and it's abstracted away from the concrete logging implementation. And did anyone ever switch the logging implementation? I didn't. So, really? We need to talk. But your mileage will vary. Just be aware of that. But what you need is deployment tooling. You can't do this by yourself. And avoid the UI. Every time somebody speaks about Lambda, they show you the Amazon UI where they click and then they test and things get created. This is a nightmare because the UI will just create things for you. They will just add permissions as it sees fit. And you have no idea what you end up, and your account will look like this. And now you can tell me what's AWS Lambda basic execution roles 6.1a crap. Total mess. So let's talk about what you need to run a Lambda. You need code, obviously. You need a handler, the entry point, yeah? It needs a name, right? You need to specify Node or Python or Java. And it needs permissions. Clear. Doing that with the command line is possible. You can see the different parts where the name is hello world or stuff like this. But looking at our example, just this tiny fraction, you need the S3 bucket. You need 3 lambdas with maybe an alias, with tagging or whatever. You need roles and policies for all of these. And you need this dynamo setup. So obviously this doesn't scale. You don't want that. So real automation. And you have multiple options like Terraform. Terraform is awesome. Forget everything I talk about. Just use Terraform and everything will be fine. I will just talk briefly about Claudia.js, and then we will look at this nice little squirrel. Claudia is basically for Node developers. I guess you as Java developers, you hate Node and JavaScript, so I won't cover that much. Just basic, if you are using Node, use this. Then there's this nice squirrel. That's SAM. And SAM is the serverless application model from AWS. It's easy idea. The idea is you have a template describing your application. Yeah? Basically, you describe what your function does, what resources it needs. You have CloudFormation that can package everything, the dependencies, the code, and then it pushes it into production or wherever you want it. Okay? Totally easy. And it's obviously YAML, because XML is crap, and JSON is crap, and YAML is king. And I guess it's self-explanatory. You declare a function, some properties, I guess the runtime, you will see it, it's Node once again, and the code and whatever. So use that instead of the command line, instead of the UI, okay? But even that isn't a free lunch. I said it sucks. Yeah, it sucks immensely because just imagine you hit your infrastructure with such a script and at one point it just stops working and it complains that some resources are already there or have been modified in the meantime. So how do you debug that? No chance. Rollback is an issue. Sometimes it can roll back changes, sometimes it can't. And you have no reason to believe that this will work in production. So sometimes just deleting everything is the only option you have. Talking about state, you have teammates, you have a CI/CD pipeline. If everybody's hitting your environment, who is maintaining the correct setup? You know, that won't be enough. But ranting about SAM, there's still this point with feature completeness. As I said, Lambda is changing so fast and Amazon is changing so fast that tools like Terraform, although awesome, they can't keep up. So there's always a delta if you want to use new features like traffic shifting. It's supported by SAM, but it's not supported by Terraform. So just be aware of crappy tools. Cleanliness is really important. And this brings me to tests. Who is not doing unit tests? Oh. Well, really? PHP developer? No. This is an awesome project. That's SAM local. The idea is, stay seated. The idea is you execute AWS on your laptop using Docker. Cool, right? Yeah, right. See the version? 0.26. Not good. Don't use that. Really cool project. Might be worthwhile in a couple of years. Right now, you do not want to use test tools that are just crappy. You want to use test tools that actually work, like JUnit or whatever. But testing lambdas is really easy. You can just invoke this command line. You know, just say which lambda, and then just a test event. the cool part is we did invoke this that way. You see, receipt upload, expensive receipt, but we hit our production environment with that thing. So that was submitted to production. So you need protection. Even in the cloud, you need staging. People tend to forget that, and they just deploy everything because some other guy said you don't need staging, you need staging. You need to protect production and development. And that's really easy too, because there are 2 steps you can do. The first step is just use postfix for your functions so that you have a clear name. Obviously, you can even apply an alias or use accounts or whatever. That's the first step. So you know that forward billing is on the dev stage. So no confusion there. And if you want to deploy that to production, you overwrite this. And you can use aliases, obviously. But what is far more important is to clean up. Because I don't know if you know this, when you start with Lambda, it's so easy to create stuff. You just say AWS Lambda create function, off you go. And then that's your architecture, just a mess. And I have no idea what I can delete. How do you reason about that? There are things there, like AWS basic role execution, blah, blah, blah. Important, I have no idea. How do you clean up? And there's this tiny tool that I really want to recommend. That's list lambdas on GitHub. And I've executed that on our development stage. And it lists basically all functions and all regions of your account, and when it was last modified and the last invocation, and I guess I can delete this test function. You can see 240, and we have lots of those things in production. Never invoked or once invoked, stuff like this, and we have no idea why they're there. Just delete them and see if things break. And why should you do why should you do this? We'll talk about security in a second. You need to reduce the attack surface. You know, everything that you deploy is exposed and can be called. So you need to keep a tight handle on that. As I said, reasoning, and it's about control. Security. Who's the security? Who? Security experts here? Somebody? Nobody raises their hand, so great. Serverless is actually awesome for security. And why? No student helper installing Ubuntu patches. That's one thing. At least you don't have to. Amazon has some student helpers who are doing just that. But thinking about security, I was wondering, how do you deploy a firewall, something like this, without web or applications or servers? So we need something else. We need new and adopted techniques for serverless. As I said, the increased attack surface is the problem. Going back to our event model, we can be called from everybody, and the caller controls basically the access rights, the privileges. They say if they are allowed to call you. So the good thing is to be a psychopath. Just imagine everybody wants to kill you. Every event source comes with an axe. That's the idea. Because you have things like event injection. Everybody knows SQL injection, right? Who doesn't know SQL injection? Everybody, awesome. And thinking about classical architectures where you have this layered cake with UI, services, and persistence, and the clear control flow. And at each boundary, you have classically some validation magic where you check the credentials, you check the parameters, and blah. But that doesn't exist in serverless land. You cannot trust your caller. Every Lambda needs the security boundary and the validation boundary. And every Lambda needs to parse its input and reject events it didn't expect. You remember I said that you have to pay for invocations. You are invoked and maybe you run for a second or maybe just 500 milliseconds. That's the amount you pay. That's gigabyte seconds. This leads to another attack, namely a billing attack. If you expose your Lambda, even if you keep rejecting my events, you are still being processed, you are still being called, you are still running, so you still have to pay. So the most important tip I can give you is the billing alarm. Set this up. There are reports out there, for example, where a guy just left his Lambda architecture running and he was hit, private project, with 800 euros of cost per week. So I recommend you avoid that and set up these alarms. At the end of the day, security is like CSS. Who's a friend of CSS? Who likes CSS? Okay, a couple of hands. I hate CSS because I can't do this. And when I encounter a web application where I have to style stuff, it's just div and then exclamation mark important, font blink, and that's enough. And the same as with security. You do not tend to take security privileges away. You just add, more and more and more. And you definitely need to beware Stack Overflow examples like this one. This is, even if you don't know IAM from Amazon, this is basically just saying you can do everything, that's the action part, on every bucket that you own. That means that function can practically do everything. This is what I call a security shotgun. That's just bam, your infrastructure goes haywire. This is the principle of least privileges. That should be our mantra, even in the cloud. First step is be specific with your resources. Be specific with the actions that you allow. That thing just says we allow only reading objects from a really specific bucket. And the same is for Dynamo tables. Just allow writing to a specific Dynamo table with a specific name. Same for other lambdas. But can we share this configuration? Can we say we have a couple of lambdas that do practically the same? Think the order example. No, do not share. Sharing is really bad. I know your mother always said, share is good, share is bad. Never share. Just write a different policy for each lambda. But this is work, right? Not with the right tooling. Back to our template. This looks like a mess, I know, but basically we declare the role and the function in the same file. And we say the policy, that means what is this function allowed to do, even in the same file. And then we just reference that role from the function. So we have everything in one concise place. And use a security watchdog, because even our functions might be small. I know you're using Maven, so you have seen what Maven and Spring downloading the internet. The same is with Node projects. Just look at this. This is just the size of the source folder and the resulting Lambda, just 8K of source code and 8 MB of Lambda. So there might be some dependencies there. And tools like Snyk can help. Who knows Snyk? Snyk? Nobody? Oh, great. You like it? I know the name, but I've not tried it. Oh, okay. You should try it. It can scan your dependencies, and it will tell you, for example, in Slack about any CVPs directly. So it's totally cool for every project. And if you're using serverless, you can use this plugin, but as I told you, we are not using serverless. The idea is that this thing analyzes your source code and generates the least privileges that you need. Really cool, but I would prefer just think about your privileges before you do that. So security is part of the development in serverless, right from the start. You all know this thing from Netflix or Amazon, I confuse it all the time. You build it, you run it, right? It's wrong. The idea is you build it, you secure it, and only then, maybe then, you can run it. Hot and cold start. There was a topic yesterday in the other serverless talk, and the idea is pretty easy, I guess. When an event arrives, we just have a new cold container. You remember containers? It's moved into a live environment that can process the event, right? Easy. And if it's warm, it can process the next event. Easy. Happens just once, right? You have a cold container, it gets started, it can stay there, right? No, we have scale by request. The idea is that an event arrives, it gets another event, and another event, and another event. And what Lambda does, scale by request, it will handle the first because that thing is warm, but it will instantiate 3 new cold containers, move them out, and process the events. That means that whoever called the other functions, the other events, will look like this, waiting for your Lambda. So cold start happens for each concurrent execution, so you have to plan with that. You have to know that if there are 500 executions in parallel, that means 500 cold starts in the worst case. But what can you do? Return to Google, as always, or Stack Overflow. And now this is the exciting part. And you start looking in the documentation of Amazon and what they tell about when they start your Lambda and how often, and you find there's no service level agreement. None. They don't promise anything. It could be that the cold start takes 20 minutes. Could be. Hasn't happened, but could. There are no details regarding what happens. They are just guidelines, you know, magic, wish thinking, chicken bones. Let's look at just 3 of them, like package size. I think the intuition would be the smaller my lambda, the faster the startup, right? Like here. We have some lambdas which obviously contain a lot of crap, 60 megabytes or 20 megabytes. And we've compared them with tiny lambdas, and there was no correlation whatsoever. Maybe if your lambda is one gigabyte big, but then I think you did something absolutely horrible. Let's look at memory. Maybe memory has some impact. Like you can assign between 128 megabytes up to 3 gigabytes, and you can see in the log how much memory your function used, so you can fine-tune that. Maybe. We found no correlation. Sometimes a function with more memory started faster, but we think it's about the frameworks. You have no way of knowing that. And then there's warm-up. The idea is basically that you have a different lambda, like the blue one, who's triggered by a schedule every 5 minutes. And it calls your function every 5 minutes, keeping it warm. You know, stays awake. And if an event arrives, it can be handled directly by a warm lambda. Great idea, right? No, it's a terrible idea because it's invasive. You have to reject those warm-up events. You know, you get called and say, oh, okay, just a warm-up call, I will go to sleep again. And think about scale by request. If you have 500 lambdas that should stay warm, you need to hit them 500 times to keep them warm. And the most irritating part is that you pay for nothing. You are just paying for an invocation of a warm function that just sticks around. And the worst part is, even if your function is warm, standing around and being called, sometimes AWS will just kill it anyway, just out of spite. I think Jeff Bezos has a big lever, just kill all lambdas at one time and everything blows up. Sometimes this happens after 30 minutes, sometimes 40 minutes. There's no clear guideline. What you can say is the more memory you allocate for your lambda, the sooner it gets killed. Yeah? The more resources. So what can you do? Pray and measure. That's the only thing that you can do. Measure user experience. If you have a web page, yeah, like a web front end like we do, then design the user experience with this latency in mind. Like with REST services, where you call a REST service and you wouldn't block the user interface in that case too. But you have some nice feedback. Same thing here. Just design your functions. Keep startup times really tiny, really fast, so that you can actually work with your lambdas. There's no other guideline there until Lambda is specified in a more concrete way. Just witchcraft. And that's directly my summary. Serverless, it's a hype train, right? And this is Comic Sans, because I'm serious. I think, obviously, this is the way forward. I think in 5 years, this will be as uncontroversial like Docker today. Everybody will look at you sadly and say, why are not you using Docker? What are you doing? And the same as serverless. I don't think that serverless, however, will solve our problems. Like designing distributed systems is still hard. I've not talked about user credentials. I've not talked about what you actually can do with lambdas that call other lambdas, like distributed failover and stuff like this. You have still to think about that. There are new attack scenarios. Like I mentioned this backend API. Just imagine if it's a database. If you're interested in the database denial of service and attack by your own lambdas, talk to me. There's the IP, VPC IP attack. The challenges are different because the language changes, nothing else. If you start that way, you need somebody who actually takes care of that. If you have a cloud ops team or a DevOps team, then you are doing it wrong. You need somebody who can help you with this AWS lingo, who can help you setting up monitoring. Like just CloudWatch is not enough. The logs won't help you. You have to use things like X-Ray. I won't cover that here. But you need somebody who actually is interested in that. The same thing with Kubernetes. Huh? Basically, it does DevOpsSec done right. And if you keep adding things to DevOps, like DevOpsSec business guy, project guy, then we are with feature team once again. But right now, DevOpsSec, that means instead of thinking about security and releasing, shortly before we go into production, we think at the first iteration. You have to start thinking about security. You are thinking about rollout right from the start. Tooling is one pile of crap, regardless which tool. I appreciate everything they are doing out there. It's just all open source, so kudos. But be aware that you will face problems all the way. And surprisingly, serverless might not be a silver bullet. It's a surprise for most of us, I know, but it's not snake oil, but not a silver bullet. I think if you tell me you are still deploying a VM for certain things, that might be totally reasonable. Yeah, I know we all want serverless in our CV and our resume, but sometimes a Docker image might totally be fine. So instead of serverless, I think of it just one less server I have to take care of. You have to do capacity planning, you have to do security, you have to do everything you're doing with Kubernetes or with your on-premise solution. It's the same thing, no difference, just different tooling. And set billing alerts. I really mean that. If you're playing around with that on your own credit card, especially if it's your boss credit card, go for it and see what happens. But other than that, billing alerts, really. So that's everything I have for you. Questions? No questions. The one question.
What you described, the requirements like auto-scaling and not taking care about, not caring about infrastructure, basically PaaS, like any platform like Google App Engine did it like 9 years ago.
Yep.
So what's the reason behind switching from application platform to a function-oriented platform?
The question was what's the, because basically this is similar to Google App Engine back in the past, just one abstraction even further, I guess, and it's not platform as a service, it's even something else. Yeah? And what would be the reason instead of going for a PaaS to a serverless application? That's your question, right? I'm not quite sure right now, because it's just so we haven't seen so many large customers of us applying that style. The thing that we are using it for is, for example, like applications where we have no real idea about scaling, what the scaling requirements are, you know. And for example, let's think something else. Like a typical example is ops glue, where you have a cloud infrastructure and you need, for example, somebody uploads a new requirement document to S3, and you have to convert that to something else. That's a special place for S3. That's the first application we've built end-to-end with no servers whatsoever. And the advantage there is that you are incredibly fast. You know, you have no approval rate between can I create a new VPC? You know, the networking for AWS. There's no approval for that. You can just create functions. You can create your web page on S3, and you have never built anything as scalable as S3. You know, S3 never falls over. Just it's there. And regarding is this a replacement for something like Google App Engine? No, it's not. I think there will be issues like Heroku is an awesome platform, but it reduces the cognitive load for most of us. I'm not a network expert. If you ask me to set up like software-defined networking for Kubernetes, no idea. With that, you don't care. You just have an abstraction on top. That's just a thing you don't have to worry about again. With the downside that there is no service level agreement, so you have to think about that. You know? One question in the back.
How do you call the lambdas without an API gateway?
I can show you in the code. It's just, you just import, basically you can, I repeat the question. The question was, I mentioned that we do not expose an API gateway. So the general pattern is that they recommend just exposing a proxy REST resource. That's just it's just crap like exposing what you do via HTTP and JSON. So it's nothing REST at all. So it's just HTTP JSON for your Lambda. What you can do is you import the AWS library in your single page application. And then you get a credential from AWS, from Cognito, that allows you to call the Lambda anonymously or with a special role if you have logged in. So it's really easy. So instead of hitting slash whatever, slash create, slash orders with a put request, you just call create order, the function itself. So the question was, so I expose a security credential to JavaScript. What you will see if you go down the serverless route is that your architectures are totally different. For example, when we started, we had a function that took some JSON payload and stored that payload in DynamoDB, a document database. Yeah? You saw that on the image. But what we found out is that you can just expose that Dynamo table directly to the browser. And it's perfectly protected using IAM. Because the user logs in using IAM, yeah, he has the credential, he has a token, and then he can just write to that single table with that single key. Completely protected, but a completely different lifestyle. If I explain that to my security officer at my customer, he will just kill me. You're exposing the database to the World Wide Web. But these are the new patterns. Like with the image upload, you always find the example where somebody uploads an image to S3, to the bucket. And there's always a Lambda that takes the payload and then stores it in S3. No, crap. You just expose the bucket for upload. You protect that bucket. It's not a public bucket. It's like you want to upload, I give you the express right for the next 5 minutes, you can upload stuff to that bucket. Completely secure. And I guess more secure than everything else that you are building right now. Question answered? Cool. Cool. Thank you. Enjoy your lunch.